So why is it that when we differentiate a sine x, we get a cos x? And when we differentiate a cos x, we get a minus sine? We have been familiar with those two formulae, but do we ever wonder why? Well, to walk you through that, we need to use what's called the first principle of differentiation. If you have no idea about what the first principle is and what it does, I recommend you check out this video using this link. So we want to differentiate a sine function first, maybe. So I write d by dx of a sine x here, and let's bring the first principle here. So the f of x that you see in the formula, in this case, would have to be sine x. So we have fx equals sine x. And that means f of x plus h would be equal to sine of x plus h. So I write here sine of x plus h minus sine of x divided by h. In order to take it forward here, we can do nothing else but to use additional formula of sine a plus b to get a better idea about that sine x plus h. We can expand that first term. So we get sine x cos h plus cos x sine h. Don't forget the minus sine x on the right, and all these are divided by h. We can pair up these two terms, and we can factor sine x out. So we have sine x in parentheses. There will be cos h minus 1 left. And the other term on top will just be cos x sine h. Again, all divided by h. Well, here, because if we have a plus b all divided by c, we can split the division into two separate terms. So instead of that, we have that over h and that over h. Not confusing, right? Now don't forget that according to the first principle, we will take the limit when h approaches 0. But don't be alarmed yet, because you might be thinking, okay, if h is 0, then that would be the division of 0. Well, it doesn't work like that. Before we jump into that, we have to make it fully simplified first. Now, the only way to simplify this is to have a look at the terms with the h. Because h is very small, so in trigonometric functions, we can use some approximations for sine and cos. So when h is very small, sine h would be approximately the same as h. You can try that in the calculator, but put h as a radian. So for example, if you plug sine of 0.001 radian in the calculator, you would get about 0.001 as well. And the small angle approximation for cos h here, when h is very small, it is approximately 1 minus h squared over 2. So let's put those two in. We have sine x, using the small angle approximation, we have 1 minus h squared over 2 here, and minus 1, all divided by h, plus h being very small, sine h would become h. So we have cos x h over h here. Two h's cancel. If you work out this whole part, you would get sine x in parentheses, 1 cancel with 1, so I have a minus h squared over 2. And if you consider the division of h down there, it would cancel 1h from the h squared. So I only have an h here, close parentheses, plus a cos x here. Now, because this is fully simplified, we cannot do anything further. Now we can apply the limit of h approaching 0. If h approaching 0, that means this whole thing approaching 0 too, and that means this whole thing approaching 0 too. And that becomes 0. That means we are only left with a cos x. So we can say that d by dx of sine x by first principle is cos x. And that is why differentiate sine, we get a cos. Now you should be able to try it by yourself to prove that differentiating a cos, why do we get a minus sign? Using the similar method here. But you might want to know that the additional formula of cos a plus b is cos a cos b minus sine a sine b. Just in case you want to use that. Oh, and don't forget the small angle approximations for sine and cos, right? And if you do work it out and want to make sure that you got it right, you can share your working in the comment section below. I'll make sure I'll go check. I hope you liked the video. Now, if you want to take differentiation to the next level, I recommend you go see all the 3 key rules in differentiation, which are appearing right now on the screen. I just spent 5 minutes to cover the basics on each of them. All right, guys, keep studying. Bye.